Good day, everyone. My topic for today is about binomial probability distribution, or simply known as the binomial distribution. So what is binomial distribution? It is actually a discrete probability distribution, which means that the number of outcomes is finite or can be counted or determined, unlike its contemporary continuous distribution. What makes it distinct is that it gives only two possible results in an experiment, success or failure. A classic example of this is tossing of a coin, in which only two outcomes are possible, heads or tails. Another example is completing a test, where there could only be two results, it's either pass or fail, or answering a question that is objective, where an answer could be right or wrong. For an experiment to be categorized as binomial distribution, it must satisfy the acronym BINS or BINS. B stands for binary outcomes. There are only two outcomes. One, if the event occurs, that is a success, and another one is if it does not occur, that is failure. I stands for independent trials, which means that the success or failure does not affect the success or failure of the next trial. Letter N stands for the number of trials, which should be definite. So there is a number N that will tell us the exact number of trials. And S stands for same probability per trial, or the probability of success or failure does not change in every trial. Let's take the following example. Rolling a die 4 times and getting the probability of rolling a 1 twice. Is this a binomial distribution? Let us check. For B, it has only two outcomes, getting a 1 or not, or that is a success or failure. So B is satisfied. For independent trials, each trial does not affect the other trials. So the second acronym is actually satisfied. The third is for the number of trial. The number of trial is actually defined as 4. It's 4 times, so the 6-sided die will be rolled 4 times. So the number of trials, N, is equal to 4. So it is also satisfied. For letter S, the same probability per trial. In every trial, there will be 1/6 chance of getting a 1, since there are 6 possible results, and getting a 1 is just one of those chances. So that is 1/6. So it is also satisfied. Therefore, for our example, rolling a die 4 times and getting the probability of rolling a die or getting a 1 twice is an example of a binomial probability distribution. What are the formulas for the binomial probability distribution? So let's have the first one for the probability. To get the probability of an event X, you need to calculate N taken X, or this is the combination of N and X, or the total of the number of ways to have a desired outcomes, or how many ways to have X successes. This is simply computed using the formula N factorial divided by the difference of N minus X factorial times X factorial. The other coefficient, we have P raised to the power of X, which is your probability of success. P stands for the probability of success, which is raised to a power of X, and the X is the number of the desired outcomes. Your Q on the other side represents the probability of failure, which is raised to the power of N minus X. The N is the number of trials minus their X, the number of the desired outcomes. So that is the formula for the probability for the binomial distribution. For the mean of the binomial distribution, that is equal to mu is equal to the product of N and P, where N is the number of trials and P is the number of success. The standard deviation, on the other hand, which is a measure of variability of a binomial distribution, is taken by this formula, we have sigma is equal to the square root of n, p, and q, where q is equal to 1 minus p. So we have to take note of these formulas, and let's have our first example. A six-sided die is rolled 4 times, and what is the probability of getting a 1 twice? Find the mean as well as the standard deviation. This is actually the first example given a while ago, and we have already proven that this is a good example of a binomial probability distribution since it followed or it satisfied the conditions given. So to solve for the probability of getting a 1 when you roll a die twice for 4 times, we will have the formula p of x is equal to n taken x times p raised to the power of x times q raised to the difference of n and x. So we simply plug in the correct values. Here, our n is equal to 4 because we are going to do the trial 4 times. X is equal to 2 because we desire to get a value of 1 twice. So twice means 2 times. So the value of x is equal to 2. So from the formula of n taken x, that is n factorial divided by the difference of n and x factorial times x factorial, we're going to substitute n with 4. So we will have 4 factorial for the numerator. And for the denominator, we have n, which is 4, minus x, which is 2. So 4 minus 2 is equal to 2. That is equal to 2 factorial times our x factorial, which is also 2 factorial. So simplifying that, we will have 4 times 3 times 2 times 1 for the numerator. And for the denominator, we have 2 factorial times 2 factorial, or 2 times 1 times 2 times 1. So applying the simplification of fractions, we can cancel out the common factors in the numerator and denominator. So we can cancel out 2 times 2 in the denominator, which is 4 in the numerator. Then we are down to the numbers 3, 2, 1 for the numerator, and 1 and 1 for the denominator. It means that the value for n taken x is simply 6. So we will substitute x for the first coefficient in the formula. For p raised to the power of x, we will just identify the value of p, or the chance of success, the chance of getting a 1 when you roll a dice. So that is equal to 1 over 6. So 1 over 6 will be raised to the power of x, which is 2, our desired outcome. That will be multiplied to q. Our q, on the other hand, since we already identified our p as 1 over 6, so the probability of failure is equal to 5 over 6. So 5 over 6 will be raised to the power of n, which is 4, minus 2. So that is 5 over 6 raised to the power of 2. To simplify this, we are going to use our calculator, and based on the computation, that is approximately 0.1157. So this means that there is 11.57% chance of getting a 1 twice in rolling a die 4 times. So we have already solved the problem for the probability part. So the probability is 11.57%. How about the mean and the standard deviation? So now let's find out the mean. The mean is equal to n times p. So we will just simply substitute our values. Our n is equal to 4 times our p, which is 1 over 6, the probability of success, or the probability of getting a 1. That is equal to 4 times 1 over 6, or 2/3. So what does it mean? So it means that if you do the trial again and again and record getting a 1 twice in every 4 rolls, because you need to roll the die 4 times, then you will get an average of 2 over 3. That is the mean. So how about the standard deviation? Using our formula for the standard deviation and simply plugging in those values, we have 4 times 1 over 6 for our P, and then 1 minus 1 over 6, which is equivalent to our Q, that is 5 over 6. That is equal to 0.5556. The square root of 0.5556 is approximately 0.745. So therefore, the standard deviation is 0.745. So what does it mean? It means that if you record the results of rolling a die 4 times again and again, and record the results, the value of the dispersion or the variation of the results is approximately 0.745. Now it's your turn to solve the problem. A die is rolled 12 times. What is the probability of getting a 6 5 times? So again, the die will be rolled 12 times, and your desired outcome is to get 6 for 5 times. So I will give you time to answer this, and I will reveal the answer in a few minutes. So the question is only for the probability. So I guess you have already computed your answers. So let's check if you got the correct answer. So again, applying the formula for the probability, the first element is the combination of n and x. We will just plug in the correct values for this problem. Our n is 12 because the trial will be 12 times. And x, or the desired outcome, is 5 because we want to get a 6 5 times. So this is simply equal to 12 factorial over 12 minus 5 is equal to 7. So that's 7 factorial times 5 factorial for the denominator. If we will do the calculation of 12 factorial, we will have 12 times 11 times 10 times 9 times 8 times 7 factorial. And remember, in the denominator, we also have 7 factorial. And for the 5 factorial, we can simplify it as 5 times 4 times 3 times 2 times 1. So since we have 7 factorial in both numerator and denominator, we can simply cancel out that value. And for the other values, we can have 4 times 3, that is equal to 12. So 12 can be canceled out as well. And for 5 times 2, that is equal to 10. So 10 can be canceled out in the numerator, leaving us with 11 times 9 times 8. And that is equal to 792. That is our first coefficient. For our p to the power of x, this is the same with the first problem a while ago. The probability of success is also 1 over 6. That will be raised to our value of x, which is 5. And our probability of failure is 5 over 6. And that will be raised to our n minus x, which is 7. So using your calculators, you will get approximately 0.0284. Or that is equal to 2.84%. So the probability is very small. It's only 2.84% for getting a 6 5 times out of 12 rows. So I hope you got the correct answer. If you have any questions or if you have any comments about this video, please do put your comment in the comment section. So that will be all for now. I hope you learned something about binomial probability distribution. That would be all. This is Ronnie. See you next time.